Have you ever wondered why your parents throw salt on the driveway when it's icy? Or why ice cream makers add salt to their ice? Today, we're going to discover the amazing science behind why salt makes ice melt, and it's way cooler than you might think. When water gets really cold, it freezes at exactly 32 degrees Fahrenheit. The water molecules start moving slower and slower until they lock together in a perfect pattern, kind of like building blocks. This creates the solid ice crystals we see. Think of it like a perfectly organized dance where everyone knows exactly where to stand. When water molecules are in this organized frozen state, they form the hard, slippery ice we all know. Salt isn't just one thing. It's actually made of two different parts stuck together called sodium and chlorine. When salt touches water, it breaks apart into millions of tiny invisible pieces. These pieces are so small you can't see them, but they're there floating around. It's like taking apart a puzzle and scattering all the pieces into the water. Even a little bit of salt creates millions of these tiny particles that change everything about how water behaves. Remember how water molecules need to organize perfectly to make ice? Well, salt particles are like party crashers that mess up the whole system. When these tiny salt pieces get in between the water molecules, they can't form their neat, organized pattern anymore. The water molecules get confused and can't figure out where they're supposed to go. It's like trying to build with blocks while someone keeps moving the pieces around. You just can't make a solid structure. Because salt makes it harder for water to organize into ice, the water now needs to be much colder than 32 degrees to actually freeze. This is called lowering the freezing point, and it can drop the temperature needed by 10, 20, or even 30 degrees. The water molecules need to move much slower and have much less energy before they can overcome the salt interference. Think of it like trying to fall asleep at a noisy party. You need to be much more tired than usual to actually succeed. When you put salt on ice that's already formed, something really interesting happens. The salt starts dissolving into the tiny bit of water that's always on the ice surface, even when it's frozen solid. This creates the same disrupting effect we talked about, but now it's working backwards, breaking apart the organized ice structure. The ice crystals start falling apart at their edges where the salt water touches them. Soon, the solid ice becomes liquid water again, even though the temperature hasn't changed. This is why salt is so important during winter storms and icy conditions. When ice covers sidewalks, driveways, and roads, it becomes incredibly dangerous to walk or drive on. By spreading salt, we can melt that dangerous ice and create safer surfaces for everyone. The melted ice turns into water that can drain away or at least provides better grip than slippery ice. Road crews use this science to keep millions of people safe during winter weather, and it all comes down to those tiny salt particles disrupting the water molecules. Salt's ice melting power isn't just for winter safety, it has some really cool other uses too. Ice cream makers use salt to make their ice cream freeze faster and smoother by controlling the temperature. Before refrigerators existed, people used salt to preserve food by controlling moisture and preventing bacteria from growing. You can even do fun science experiments at home using salt and ice to create super cold temperatures for making instant ice cream. This simple chemical reaction has been helping humans for thousands of years in ways you might never have imagined. What's the most creative way you can think of to use salt and ice together, maybe for a science project or just for fun?